Okay, so here question is, a clock with a iron pendulum keeps correct time at 20 degrees centigrade. So correct time it is showing at 20 degrees centigrade. Now what will happen if we change the temperature to 40 degrees centigrade? Basically there is a pendulum na. If we know that time period of a pendulum T is equals to twice pi root under L by G. Now this temperature depends on length, right? And this time period depends on length, and also temperature is dependent on length. Basically when you are going to use this formula, T is equals to twice pi root under L by G, T is what? T is temperature, not T is time period, not temperature. Okay, and at 20 degrees centigrade, let's suppose its length is L at 20 degrees centigrade. Now what will be the change? Means what will be the change in if we change the temperature to 40 degrees centigrade? In that situation we will get simply L dash equals to, or change in length delta L is equals to L alpha delta T. We know this formula already. So now from 20 degree centigrade to 40 degree centigrade we are changing. That means delta L is the change, right? Delta L is the change. So delta L is equals to L means at 20 degree centigrade what was, it is L into alpha into delta T is the change in temperature. So 40 minus 20, 40 minus 20. So basically we are getting 20 L alpha, right? 20 L alpha is the change in temperature, change in length for increasing the temperature. Now what is the value of alpha? Here cubical expansion means gamma is given, right? Gamma is given, and we know the relationship between alpha and gamma. What is the relationship? Alpha is equals to beta by 2 is equals to gamma by 3. We already know this relation na? So alpha equals to gamma by 3. So what is the value of gamma? This one. So just divide it by 3 to get the temperature length linear expansion coefficient. So 12 into 10 to the power minus 6 degree centigrade. Degree centigrade, no, degree centigrade inverse it will be. Yeah, it has some misprint. Degree centigrade inverse. Okay, so this is the value of linear expansion coefficient, and delta L is equals to, we are getting 20 L into alpha means 12 into 10 to the power minus 6. So basically 240 into 10 to the power minus 6 means we can write down 2.4 into 10 to the power minus 4 L. Okay, this is delta L. Now one thing we can do, because we need to find out the change in the T, right? Change in T we need to find out. So basically T is equals to all the terms like 2 pi G, all these are constants, so we can take at constant, take them as constant, 2 pi by root G and root L. Root L means what? Root L means L to the power half. Now simply delta T by T we will get half into delta L by L, right? Half into delta L by L. So delta T by T is equals to half into delta L means what? Delta L means this, and when we divide it with L, so this L and this L will cancel out, right? So after cancelling these two we will get 2.4 into 10 to the power minus 4, basically 1.2 into 10 to the power minus 4. This is the value of delta T by T. Now we have to find out the variation, right? This is the variation, and in percentage if you want to find out the loss or gain in time, then what you have to do is just multiply it with 100% at both side. So you'll get percentage change. Okay, this will be the answer, and obviously time period will increase. Okay, so this is the correct answer, and in percentage unit, and obviously gain will be in here in case of when length of the pendulum is increasing, then you can also guess here that L is directly proportional to the square root of L. So obviously if we increase the value of L, then time period will increase, and with the temperature length increases. So I hope it is clear to you, right? If you have any doubt, you can comment in the comment section. Thank you.